My subject is going to be chemistry, but again, if you have some doubts in Python also, you can ask me. My research is like it is based on Python. I have to use Python for that. And in chemistry, almost all the batches, they have completed the chapter that is solution. Okay, one thing is that. And the second thing is most of the batches, they are going to start, because in their school, most of them, they have started haloalkane and haloarine. So now there are a few students who have started at electrochemistry. So there will be a completely new batch for the student who want to go after solution. They want to go to electrochemistry. Okay.
Okay.
So for this, I'm thinking, now we have not decided with the time yet, but today is what, Tuesday and Thursday. No? So Tuesday and Thursday. What is the time right now there?
5:36.
5:36. So around 6 p.m. to 7:30.
I think I gave the days as Monday, Tuesday, and Wednesday. That's what I gave.
Monday, Tuesday, and Wednesday. Actually, you
Yeah.
have given the day. Okay, Monday, Tuesday, and Wednesdays. Okay, fine. Then I have to see something on Monday and Wednesday. So that then the management will figure it out. Monday and Wednesday ke bare mein. Okay. Now,
Okay.
in solution chapter, let us start with my topic then. In solution chapter, there are many subtopics that you can see. How many topics are there? Concentration term is there. Now, that is basically in what ways we can define the concentration of a particular solution. Concentration means the amount of solute present in solvent or solution. Okay. After that, we have portions such as Henry's law. Then we have Rod's law. Both of these comes under the topic of solubility. And Henry's law is also a specific, it has a specific meaning in solubility because it says about the solubility and how the pressure affects the solubility of a liquid gas system. And after that, after Rod's law and all, we have topics such as azeotropes. That is deviations from the Rod's law, azeotropes. And at last, you can say that we have colligative property. And then we have abnormal molar mass. Okay, so these are the different topics in solution chapter. Now, what I think we should be doing is that, will it be fine that we start with, are you okay with concentration term? First of all, that. If you're not okay with concentration term, then we cannot start electrochemistry at all, because electrochemistry means we need concentration term. And in chemical kinetics also we need concentration terms. So first of all, tell me, Ryan, how much are you clear with concentration terms? Yes, Ryan?
So like now you want me to start with, so you're gonna start with concentration terms.
No. What I'm saying is, what I was planning was, with the regular batches, we will do electrochemistry. Okay? And then I will be giving you extra classes. In that, I will be teaching you solutions. पढ़ाएंगे तो दोनों ही, है ना? So in the regular batches.
I don't know Hindi.
Achha, you don't know Hindi? Where are you from?
I'm actually from Tamil Nadu.
Tamil Nadu. Okay, fine. But you don't understand Hindi. Okay, what I am saying is that we will have extra classes. In that, I will be teaching you solution. Okay.
Okay.
In that you will be only there, and maybe some one or two students who want to revise solution chapter. And in the regular classes, we will be teaching electrochemistry, in which you will be in a particular batch. There will be few students there who all will be learning electrochemistry. Okay. But in order to start electrochemistry also, I need you to be okay with concentration term. So I'm asking, like, kitna aapne padha hai? Like, sorry again for my Hindi, but have you learned any of the solution chapter? Like, or is there nothing? You have not done anything in solution?
I have done Henry's law.
So you have some idea. There are some words in your brain which is related to the chapter solution. Okay, fine.
Yeah, I did.
Understood. Okay, fine. When I say solution, then in your head you're like, okay, Henry's law, Rod's law, there are some terms that are there, but not concrete idea. Okay, fine. Then I will give you a slight idea about the concentration terms, and more specifically, what I will teach you now in a way that it is possible for you to solve questions, right? I want you to gain confidence in solution chapter as soon as possible. You will start directly with one of the questions, and after that you will be feeling somewhat okay with the terms that are used in concentration, sorry, terms that are used in solution chapter. Is that okay? Yes or no? Tell me.
Yeah, okay.
Okay, fine. So let us start with the question. Acha, also one more thing, you have heard these terms now: molarity,
Yeah.
molality, right? Mole
Yes.
fraction, है ना? Acha. Now, even though you must right now you don't know what is molarity, I'm assuming that right now you don't know what is molality or mole fraction. But if I tell you the formula, then you will be like, okay, yes, in 11th standard I did remember. I did these type of questions, right, Rayan?
Yes.
Okay, fine. So just I'm assuming that you will remember these things, and I'm starting with a very heavy heart, है ना? Directly with the question, okay? Directly with the question. Chaliye. And pardon my Hindi for sometimes, okay? It's just a
It's okay.
habit. Okay, fine. So where are you from in Tamil Nadu?
I'm near to Tirvarur. It's like that.
I don't know where that is, but I hope it is a good place. All right, calculate. Number one, molality. Number two, mole fraction. And molarity of Ki if the density of 20% mass by mass aqueous Ki is 1.20 grams per ml. Write this question with me, Rayan.
Okay.
Let me know when you're done writing the question.
Okay. Yeah, done.
Done? Okay.
Yes.
Now, in this question, we have been given information which is very minimal. It is 20% mass by mass aqueous Ki, and the density of 20% mass by mass aqueous Ki is 1.20 grams per mole. Okay. Now, here we need to translate this chemical information into plain English. First of all, I will I will teach you that how to translate this. See what we have: 20% mass by mass. Mass by mass is also written as W by W. Okay, so I'm writing it as W by W. Mass by mass aqueous Ki. Now, this aqueous Ki, aqueous means it is solvent as water, and Ki is the solute. First of all, we now know what is the solvent, and we also know what is the solute. Yes or no?
Yes.
You got it, Rayan? Okay. Also,
Yeah.
solvent is something which is in larger amount or smaller amount. Tell me, what do you think? Solvent is something that is in large amount or small amount?
Large.
Large amount. See, very good. Large amount. And solute is something that is in small amount, right?
Yes.
Okay. I will represent solvent as A and I will represent solute as B. Okay. So if I write number of moles of solute and then I will write it NB, number of moles of solute. If I write mass of solvent, I will write it as WA. Is that clear? Yes or no, Rayan?
Yeah, it is.
Fine. Now then we have this information that is 20% W by W, 20% W by W. Now we need to translate this. Okay, so we'll translate this statement. This is very important. It means 20 gram of Ki is present in 100 grams of solution. Okay, now can you translate anything which is something percentage W by W? Yes or no? Tell me that.
Yeah.
So if I say it is 10%, that means you will say 10 gram in 100 gram of solution. Remember this, that it is 100 grams of solution. Okay, please remember this. Okay, not solvent, it's 100 gram of solution. Clear? Eh?
Yeah.
Okay, now I can also write this another statement, 20 gram of Ki dissolved with 80 gram of water, right? And that is why 80 gram of water and 20 gram of Ki, they are making 100 gram of solution. Clear? Eh? Is this clear, yes or no?
Yes.
Right. So these see, very basic statement that is 20% is W by W. We have to convert this into plain English in order to get the solution. Okay. Now we will calculate the molality. Now we will calculate what? We will calculate the molality. What is molality? First of all, we have to look at that. Molality is moles of solute per kg of solvent. That means we need two things. We need the number of moles of solute and we need the mass of solvent in kg. Yes or no? Is this clear? Okay. Now just wait a second. Number of moles of solute. So what I will do, NB, this will be equal to the WB, that means the given mass of solute divided by the molar mass of solute. Yes or no? You know this formula for number of moles, calculating number of moles, yes or no?
Yeah, I've seen.
Okay. So what is the given mass of solute? Tell me. What is the solute here? What is the solute here, Rayan?
It's 20, right? 1 point.
20.
No.
20 grams. Yeah, correct. 20 grams of Ki, na? Ki is the solute, right?
Yeah.
And 20 grams present in the solution. That is why 20 grams. Molar mass, I will tell you now. For Ki, it is equal to 166 grams per mole. So grams and grams will cancel each other. Now I'm just keeping it here. Okay, I'm just keeping it here. And then we have to see the mass of solvent. So I will write mass of solvent as WA in terms of kg. So we have this 80 gram divided by 1000 and it will give me kgs, right? 80 divided by 1000 will give me kg. So this will be equal to how much? Kg, right? Now number of moles of solute per kg of solvent, that means molarity which is given by small m, it is equal to NB upon WA. NB is 20 upon 166 into 0.08. Is that clear, yes or no?
Yes.
Can you please copy till here and solve for m? Please copy till here and solve for m. Let me just plug in my charger for a second. Okay, you can copy. You need some help in solving this?
Is it 0.664?
Okay, I missed you somewhere. What?
664?
0.664. No. Okay, so let me solve this. Hai na? 20 upon 166 into, I can write this as 8 upon 100, and this 100 will go above. So one suggestion that I will always give you is that to get rid of the decimal points, okay? Always solve with whole numbers. Now, what do we have here? This is 20 into 100. That will be 2000 divided by 166 into 8. Try solving this now. Maybe you can get the answer.
No, not getting.
Not good. Okay, fine. So if I see 8, what I can do? 4, this will be 1000, right? 4, this will be 250. Now we have 250 by 166. Correct? Yes or no?
Okay.
Right. Now you want to try? Or should I continue? Tell me.
Yeah, continue. Let's see.
Continue. Okay, fine. So after this, again, 8s up, right? And then 3s up. And this will be 125. Correct? After this, you must have to 125. So 83 ones up. It will be 83. How much will be remaining? You have your 5, 3, it will be 2, and 12 and 8, it will be how much? 4, right? I will give a point here and I will give a 0 here. Correct? Now, 8 5s is 40, right? So I can also do 83 into 5. So it must be somewhere near to 420. 83 into 5. 5 is a 50. 8 5 is a 40 and 41. So this is 5. And this is 415. And you will get here 5. Then I will add a 0. So it is not divisible. So I will add a 0 here. Then I can add a 0 here. And after that, I think it will be equal to how much? 506 I can go now. I think 506 I can go. It will be something, but I don't need that much value. I can just write approximately equal to 1.5. This was mole. And in the denominator, we have kg. So it will be mole per kg. Got it, Ryan? Yes or no?
Okay. Yeah, but we found this for this is for
Tell me, this is what?
mole fraction. We found this for molarity, right? This is molarity.
This is a molality.
Okay. Because first you gave molarity. Okay. First you gave molarity or molality.
I gave molality only first.
Okay, I wrote molarity. Fine.
Actually, you wrote
Second.
molarity.
Yeah.
No, I have written molarity at the end because of one reason that you will get to know. Okay.
Okay.
Now, next is what? Next we have. Actually, let us do one thing here. Let us find what is 20 upon 166. It will be helpful for us. Okay. Can you divide this 20 upon 166? How will you solve this? That is the number of moles of Ki, na? Number of moles of KI, it is equal to 20 grams. That is the in solution divided by 166 grams per mole. How will you divide this? Tell me. This will be equal to how much? Again, I can write this as 83 and 10. So point and 0, then 1 will be 83. So 17 will be remaining, right? Yes, 17. And then 0. So it will be 83 twos, I think. Yeah, 166. Right. So this will be the again 4. And then again, I have to give a 0. I have to give a 0. So I can write this approximately equal to 0.12. See, there is a basic law that you can follow.
I'm actually kind of weak in this. Like, it takes time to solve. So
Okay, fine. But you have to work on this because the solution chapter, electrochemistry, chemical kinetics, they all have these type of, this is arithmetic, right? This is not mathematics, correct?
Yeah.
Anna? So you have to do something. When is your holiday starting? Tell me. Kuwait में कब से आपकी छुट्टियां हैं? Oh,
June
sorry.
7.
Summer vacation. Chutti means vacation. Yes, Rayan. When is summer vacation?
June 17.
June 17th. Okay, fine. Now in the summer vacation, okay, how much tables do you know?
I mean, yeah, I know. But like, after 12 and 15, yeah, I just, solve it. And I see.
Okay, fine. If I say, see, there are few things that everyone should know. For example, I will ask you a few simple questions. Okay. Can you please turn the mic on?
Yeah.
9 plus 5
Huh?
is how much? 9 plus 5 is how much? 9 plus 5.
11.
What did you hear?
9 plus what?
What did you hear? 9 plus what did you hear?
Can you say again? I don't understand.
Okay. 8 plus 6. Tell me.
14.
Acha, you have to do these things.
I mean, like, I can, but sometimes it doesn't come to my mind. I
Huh.
don't have to
So,
do these things.
okay, but like you have to practice that single digits. Just wait a second. Ji sir. Yes, okay. Rayan, so one thing is that you will get a link for biology trial class that you
Okay.
will receive just you will receive it just now. Okay. You must have got a link previously, right?
Yeah, I got. Yeah, I got.
You got it now also?
Now I didn't check 1 second.
So you just join the recent one, okay? Not the old one.
Oh, now I didn't receive anything.
ठीक है, you will receive it, okay? You will
Okay.
receive it as soon as I will end the class. Then I think you will receive it. So one thing that I will ask you is to be very good at single digit addition, subtraction, multiplication, and divisions. Okay, it should be in your fingertips.
Oh,
Okay.
actually, like, I mean, what happened was that the problem is that, like, I used to change schools, so frequently, so everything got mixed up, and so
No
everything got
problem.
confused. It's because of the teachers, and that's why I kind of stuck in
I
math.
understand.
So it's
I
not.
understand that, but it's workable, right, Rayan?
Yeah.
That's the. I mean, that's what the thinking that you should always have. It's if it is workable, then you just need to put in hours, right?
Yeah.
Hai if you just put in some hours, it will be fine. So don't worry about that. Okay.
Okay.
Like you must be lagging somewhere, but it is not that कि उसके लिए आप कुछ कर नहीं सकते. Sorry again for sorry for my Hindi. I'm just saying that it's just that you can work on it and it will be fine and you will be same as similar students. And like this is very common problem. Okay, even if you have switched schools and all, this is a very common problem that many students, they are not very good at arithmetic problems. Okay, so you'll work on it together, and I will tell you tricks, tips and tricks and how to solve these calculative problems. Okay.
Okay.
Fine. Now I think the time is there for your biology class. So I think we could not complete this question, but we will meet again soon. है ना? And we will be starting with solutions only. We will be completing solutions major portions, and then parallelly we will be doing electrochemistry also. Okay, Rayan?
Okay, fine.
Okay, fine. Chalo. So I think you will get the link now for biology.
Yeah, I got.
You can join
Yeah,
it.
I got.
Got it. Ah, okay, fine. Join it.
Okay.
The teacher will be waiting. Bye. Thank you.
Thank
Take
you.
care.
Thank you.
Bye bye. Assalamu alaikum, sir. How are you? Hello, sir. Am I audible?
Yes, sir. Yes, sir. I'm fine.
Long time, huh?
Yes, sir.
What happened?
I went out, sir. The first week was exams, and the second week was I was out.
Okay. Okay, for Umrah. Okay, fine, fine. I hope you prayed for me.
Yes, sir.
Do you remember it? Do you remember me in your prayers, huh?
Yes, yes.
Or you did not? Yes? Sure.
Yes, sir. Yes.
Pakka.
Yes.
Thank you. Thank you so much. Okay. So let us just wait. I think some students may join. I mean, it was such a coincidence that I shifted many students to the batch just before this, like the B batch, and then you were not there. And I think again some of the other students, they were also traveling, so no one was coming to the class. I don't think in syllabus has like what was the last class that you did, sir?
Last class.
Hmm.
Ideal and non-ideal solutions.
Ideal and non-ideal solutions.
Yes.
Okay, so you have not done positive deviation and negative deviation, I think, right?
I have not done, but I saw a video.
So you saw the video. So that is the last class only. I mean, like after 24th May, you can see that like there is no videos. 24th May, na. So 24 May was Tuesday. So at least 3-4 classes has been not happening. So let us see for 1 or 2 minutes more. Then we will start. Okay.
Yes, sir.
Assalamu alaikum, Sayyida Rufia. How are you?
Walaikum salam, sir. I'm fine, alhamdulillah.
What happened with you? We are not present in last few classes.
Yes, sir. My network was not coming properly, so I didn't even attend the physics classes.
Oh, okay. Now is it
Yes,
good now? Is it fine?
Yes, it's good.
Achha. Okay. So now, like, where are you right now? Are you in India or somewhere?
Sir, actually, I'm in Jeddah now, but I'm shifting to Riyadh. So
Okay, okay.
I will be missing some classes, but later after exams, I'll be shifting to Riyadh.
Okay. When is your exam?
Sir, it's next Tuesday.
Next Tuesday. Which chapters are coming?
Physics.
Oh, you have this physics examination.
Yes.
Okay, fine. Okay. So what was the last class that you attended, Sayyida Rufia? Hmm? What was the last class? Yes, Sayeda Rukia.
Yes, sir. Sir, we finished the Rawls law.
Rawls law was over, that is for sure. But what about this? Positive deviation from Rawls law and negative deviation from Rawls law.
Yes, sir. We finished that.
You finished that, no?
Yes.
Okay, fine. Okay, and Saf, you have watched the lecture. Do you have any doubts, Saf? Hi, Saf. Hello, Saf. Am I audible? Azeotrope is also done, no? I think we can start with colligative properties. Okay. Rufia, am I audible, right?
Yes, sir.
Okay, fine. So we have seen a few laws, right? We have seen Henry's law. So what was Henry's law? It talked about the liquid plus gas systems. Now, liquid plus gas systems, what do they have? They have liquid and gas, and the pressure, it is equal to kH into chi b, mole fraction of the solute. In this, kH is for kH is what? kH is for the solute that we have added, for the gas that we have added, right? And mole fraction. That means the pressure is dependent on the type of solute that you have added. For example, if you have added nitrogen, then the kH will be different. If you have added methane CH4, the kH will be different. That means the pressure depends on the type of gas you have added, and also the mole fraction, also the amount of solute that you have added. Similarly, if you see the Rawls law, in Rawls law, what do you have? In Rawls law, we have pressure is equal to P naught A chi A plus P naught B chi B. Here also you can see the pressure is dependent on the type of solution, type of solute that you have added, A and B, and also it depends on the masses. It also depends on the amount of solute that you have added. But the properties that we are going to study right now are the properties that only depend on number of solute particles. What do they depend on? Only on the number of solute particles. They don't depend on the nature of solute particles. They depend on what, say the Rukia? What do they depend on?
Solute particles.
Number of solute particles. What do they depend on?
Number of solute particles.
Number of solute particles. Okay, so please write the topic. Now these properties, these are known as colligative properties. Write the topic, colligative properties. So please write the definition. The properties that depend only on the number of solute particles and not on the nature of solute particles, and not on the nature of solute particles are called colligative properties. Okay, these properties are also known as what? Democratic democratic properties. Also known as democratic property. Democratic properties, why? Because they depend on the number. In democracy, what depends? What is the value? Value is there in numbers, not on the nature, right? That is why these are colligative properties. These are also known as democratic properties. This is clear, yes or no, Sayyid Rufi and Saifullah?
Yes, sir.
Okay. Now, Saif, did you get disconnected for a while?
No.
Okay. I was calling you for a long time. You did not answer. Please write there are 4 colligative properties. Okay. What are the 4 colligative properties? Number 1, relative lowering of vapor pressure. Relative lowering of what? Relative lowering of vapor pressure. Relative lowering of vapor pressure, what will happen? RLVP. You will write it in short, RLVP. Okay. Second point is relative lowering of vapor pressure. Second is elevation in boiling point. Third is depression in freezing point. Depression in freezing point. And the last colligative property that we'll be learning is osmotic pressure. Osmotic pressure. Osmotic pressure. Please write this down. Let me know when you're done. Let me know if you're done. Yes, say the Rufi and Sayaf. Please let me know when you're done. Okay. Okay. Sayaf is done. Sayyida Rufia, done. Okay, fine. Now, please don't write anything. Just listen, okay? So in solutions, we have seen till now solutions in which the solvent is liquid and the solute is gas. We've also looked at the solutions in which we have solvent, liquid, and solute is also liquid. And also there are solutions in which we can have liquid solvent plus solid solute. Okay, liquid and gas. So if we have liquid and gas, then in that type of solution, what we'll be having? We'll be having some vapor pressure here, right? We will be having some vapor pressure. Now, you will tell me, Saif and Seda Rufia, if I compare the capability of liquid and gas, if I compare the tendency to get vaporized, which can escape easily, liquid or gas? What will escape easily? Liquid or gas? Gas will escape easily, right? And that is why the Henry's law, it states that pressure is equal to Kh into chi b. That means it is dependent on the mole fraction of the gas. Yes or no, Saif? Got this? Yes or no, Saif? Okay. Now in liquid and liquid, what do you think? both has almost equal escapability, yes or no? Please tell me.
Yes, sir.
Right? And that is why Rawls law says that P is equal to P naught A chi A plus P naught B chi B. Here you can see it depends on both the mole fraction of solvent as well as solute. But in the case where we have liquid solvent and solid solute, in this case, what do you think which has escapability? Only liquid, right?
Yes, sir.
And that is why the pressure. Now solid, it cannot escape because solid, it cannot vaporize at normal temperature. You have to heat it around. Right? So the pressure in this case where you have liquid and solid solute, pressure will be directly proportional to chi A, and P will be equal to this P is what? P total. Okay, this P total or P solution. It is equal to P naught A chi A. Is this clear? Yes or no? Please tell me.
Yes.
Now, what I will do? Now let us write. Now let us write relative lowering of vapor pressure. Relative lowering of vapor pressure. Of vapor pressure. Okay. Now, in relative lowering of vapor pressure, what do we have? First thing is that you should have a non-volatile solute. That means you should have a solid solute. Solid solute is non-volatile. It does not get into vapor. It does not get into vapor. Please write when a non-volatile solute is added in a solvent, the vapor pressure of solution decreases and gets lower than that of pure solvent. And obviously, see what happens if you have pure solvent, all the surface it will have solvent particles, that is liquid. But as soon as you add some non-volatile solute, in this surface you will have some particles which are occupied by the solute particle. Please don't write anything, just listen now. Some of the surface area is what it is getting occupied by the solute particles, and the solvent molecules, they are getting vaporized, but it is not getting vaporized as much as it was in the pure state because of again the same thing. Some of the surface area is getting occupied by the solute particles, which is hindering the vaporization of what? Which is hindering the vaporization of solvent molecules. And that is why the vapor pressure of the solution becomes lower than the vapor pressure of the pure solvent. Is this clear? Yes or no? Please tell me.
Yes, sir.
Now, we delete this part. What we have seen till now, we have seen that as vapor pressure will depend, vapor pressure will depend only on the amount of solvent, we can write pressure of solution or pressure of solution or pressure total will be directly proportional to the chi A. And in order to remove this proportionality sign, we can write P total will be equal to P naught A chi A. But this is only for a solution having non-volatile solute. Also, as we know, P naught A and chi A can be written as 1 minus chi B. Why? Because chi A and chi B is equal to 1, and we can write chi A as 1 minus chi B. Okay. Next thing is, I will open the bracket P naught A minus P naught A chi B, and this is P total. Now, what I will do here, I will write P naught A. Sorry, I will write P total. Let me write P naught A only minus P total. This will be equal to P naught A chi B. Is this clear? Yes or no? Please tell me. है ना? Just wait a second. What is P naught A here? P naught A is the vapor pressure of pure solvent. Vapor pressure of pure solvent, okay? Minus P total. P total is the vapor pressure of the solution. And this part, this is what it is telling me about the decrease in the vapor pressure. That's why this equation denotes the lowering of vapor pressure. It denotes what? Lowering of vapor pressure. Now, when I divide this by P naught A, it is telling me per P naught A how much it is lowered, and which will be equal to chi B, and this is known as relative lowering of vapor pressure. Okay, this is lowering of vapor pressure, and this is giving me the relative lowering per P naught A. That is why it is known as relative lowering of vapor pressure. Okay, and this is only dependent on chi B, that is the mole fraction of the solute, and it does not depend on the nature of solute. It does depend on the, it just depend on what? It just depends on the number of solute particles. Will you please write this down? Let me know when you're done. Is everyone done? Saf and Rufia? Okay. Write the topic. Determination of molar mass of solute. Determination of molar mass of solute using the relative lowering of vapor pressure. Okay. This one disclaimer should be there, that this is only for dilute solutions. Okay, it is only for what? It is only for dilute solutions. Now we have seen what is relative lowering of vapor pressure. It is equal to P naught A minus P total, that is P solution, divided by P naught A. This will be equal to chi B. And we also know mole fraction is equal to what? Mole fraction is equal to number of moles upon Na plus Nb. Okay. Now, when we have dilute solution, we can say that number of moles of B is very smaller than number of moles of A, and hence we can write this as P naught A minus P total upon P naught A is equal to number of moles of B divided by number of moles of A. We are neglecting the NB here because it is comparatively very small. And now what you can do? You can write NB is equal to what? Number of moles of B is what? Given mass by molar mass multiplied by number of moles of A will be equal to how much? It will be equal to the given mass of A divided by molar mass of A. So it will go above and it will become molar mass of A here, right? P naught A minus P total divided by P naught A. Okay. Next, MB is equal to what? MB will be equal to P naught A upon P naught A minus P total into WB into MA upon WA. Write this down. Let me know when you're done. I need to scroll up, right? Now see, don't put much time in memorizing this formula, okay? Because you have to memorize this whole process from here to here. CBSE, they will ask you directly a question: how would you determine the molar mass of a solute using relative lowering of vapor pressure? Okay, please write this down. Let me know when you're done. Then we'll do some questions. Raise your hand if you're done, okay? Acha, both of you have raised your hand. Okay, fine. So let us write a question. I did not get any notification for raising hand. Write a question. A solution is prepared by dissolving 10 gram of non-volatile 10 gram of non-volatile solute in 200 grams of water. In 200 grams of water, the solution has vapor pressure a vapor pressure of 31.84. Okay, I'm just writing this down, okay? Just so you can copy this. let the azan complete and then I will start. Okay. Okay. So Saif and Sayeda Rukia, both of you have written the question, yes or no?
Yes, sir.
Yes. Okay, fine. So in this question, what they are saying, they're saying that a solution has been prepared by dissolving 10 grams of non-volatile solute. That means solid solute in 200 grams of water. The solution has a vapor pressure. They have given the vapor pressure of solution. Okay. They have also given 10 gram of non-volatile solute in 200 grams of water. They are saying calculate the molar mass of solute if the vapor pressure of pure water is 32 mmHg. 32 mmHg. They have also given the vapor pressure of pure water. So you have got few things, that is P total is given. That means P solution, that is 31.84 mm of Hg. The P naught A for solvent, it is also given 32 mm of Hg. They have also given you, this is 10 gram, right? So this is all, they have also given you the WB, that means the amount of solute in solution, 10 gram, and WA is also given, that is equal to 200 grams. And the molar mass of A, since the molar mass is what? Of H2O, right? So molar mass of H2O is equal to 80 grams per mole. So all of these things are given, yes or no? Please tell me. Yes or no, guys?
Yes, sir.
Yes, sir.
And then you can plug in these values in this formula, above formula. MB is equal to P naught A upon P naught A minus P total. यहाँ पे not नहीं है. Okay. Into WB into MA upon WA. All of these are given, yes or no? Right.
Yes.
And you can calculate the molar mass of solute. So MB will be equal to what? MB will be equal to P naught A into WB into MA divided by what? P naught A minus P total multiplied by WA. So P naught A is 32 into WB is how much? 10 grams. MA is equal to how much? 18. Let me ignore the units, okay? We'll write the units at the end. P naught A 32, WB is 10, MA is 18, 32 minus 31.84 into WA is 200 grams. Okay, so this is mmHg into 10 grams into grams per mole divided by this is also mmHg into 200 is grams, right? So mmHg will get cancelled, grams and grams will get cancelled. You will get the answer in grams per mole. So please calculate this. Is Saf correct? Sridhar, Rufia, waiting for your answer. Sridhar, Rufia, what happened? You're not getting the answer, Sridhar, Rufia? Okay. Let's write one more point. Graph for relative lowering in vapor pressure. The graph is pretty simple in this case. Now I will be plotting vapor pressure against the mole fraction of A. So when you have solid solute, when there is no solvent, what will be there? You will be having only the chi A will be equal to 0 and chi B will be equal to 1. And this chi B is what? It is solid. If you have anything solid, it will have no vapor pressure. Okay, that means it will be 0. And when I go forward, and this here, chi A will be equal to 1 and chi B it will be equal to 0. At this point, what we'll be having? We'll be having P naught A. The only the vapor pressure of pure solvent. And the plot will look something like this. Will you please write this down? Let me know when you're done. Yes, Saf, are you done?
1 minute, sir.
Okay. Yes, Saf, done.
That's
Okay. Now, let us suppose we have a container. In this, what we have only pure solvent. What do we have here? SAF. What do we have in this container, SAF?
Liquid,
Sorry,
liquid water.
pure solvent, pure solvent. To say that this is container A. And there is a similar container. In this container, we have solvent as well as some solid solute, okay? Plus solid solute. It's going to be B. Okay. Now, so Saf, tell me, where do you think there will be more vapor pressure, in A or B? Yes, Saf.
In A, sir.
In A, there will be more vapor pressure. Okay. Now, in order to boil, we know the vapor pressure of A is greater than the vapor pressure of the B. In order to boil both the liquids, both the solutions, both the liquids, they have to reach a vapor pressure which is equal to 1 atm. Is that right? Yes or no?
Yes.
Okay. Now you tell me which of them will easily reach 1 atm vapor pressure, A or B?
A.
A will reach 1 atm very easily. That means in order to boil the solution, we need more temperature, right?
Yes.
Right? And this is known as, since the boiling point of the solution is higher than the boiling point of pure solvent, this increase in the boiling point is known as elevation in boiling point. That is the second colligative property. So please write this with me. Elevation in boiling point. Now, right here, boiling point is a temperature. Boiling point is a temperature at which the vapor pressure, boiling point is the temperature at which the vapor pressure is equal to the atmospheric pressure. Okay. Next point. Since the vapor pressure of solution with solid solute is lower than pure solvent, the solution boils at higher temperature. The solution boils at higher temperature. This increase in the temperature this increase in temperature, okay, this increase in boiling point temperature is known as elevation in boiling point. Done? Saf. Oh, Rufia is also here. Rufia, did you understand this point? Yes, say the Rufia.
Yes, sir.
Did you understand this elevation in boiling point?
Sir, I came a bit late. I got disconnected.
अच्छा तो लिखा कि नहीं आपने अभी?
Yes, sir, I'm writing.
Write it and try to understand while writing, okay?
Okay,
You will
sir.
understand it. If you don't, then I will explain it again.
Okay.
Yes, say the Rufia done.
Yes, sir.
Did you understand it?
Yes, sir.
Okay, very good. Now let us look at the graph of elevation in boiling point. Okay, graph for elevation in boiling point. In this graph also we will compare the vapor pressure and temperature. So please don't write now. Please look at the graph and then you will write when I am explaining, after I am done explaining this, okay? Now, whenever we are talking about boiling point, a particular vapor pressure is very important to us, that is 1 atm. So we'll mark this point and this line in this y axis, it represents 1 atm. Now, let us suppose we are starting at 25 Kelvin, sorry, not 25 Kelvin, 298 Kelvin, that is the room temperature. There must be some vapor pressure. So let us suppose this is the point where it represents 298 Kelvin and some vapor pressure. And as soon as I start increasing the temperature, what will happen to the vapor pressure? It will increase or decrease. Saf and Saida Rufia. If I increase the temperature, then what will happen? Will form more vapors or less vapors?
More vapors.
More vapors, yes or no? Saida Rufia.
Yes, sir.
Hai and if you are forming more vapors, the vapor pressure will increase or decrease?
Increase.
It will increase, right? And slowly it will reach to the top, that is 1 atm. Correct? Yes or no? Please tell me, guys.
Yes, sir.
Now,
Yes.
this is for solvent. This is for solvent. Blue is for solvent. Now, for solution, the vapor pressure of solution is a bit less than that of solvent, right? We have just seen in relative lowering of vapor pressure, the vapor pressure of solution is bit less than that of solvent. And if I increase the temperature, the vapor pressure will increase and it will get to boiling point in this temperature. Now what I will do, I will drop a perpendicular from here. Okay. Similarly, I will drop a perpendicular from here. So this is the point where this what's the solution. So we will represent this as TB, and this is the point where we have the boiling point of solvent. So we'll represent this as T naught B. So which is higher, TB or T naught B?
TB.
TB is higher. And this will be the difference between TB and T naught B will be given as delta TB. Okay. So write delta TB will be equal to TB minus T naught B. TB is boiling point of solution. T naught B is boiling point of solvent. Delta TP is elevation in boiling point. Write this down. Let me know when you're done. Done, guys? Yes or no?
Yes.
Okay. Now you both will tell me if I increase the amount of solute, what I am doing? Can you please tell me what I'm doing? I'm increasing the amount of
Solute.
I'm increasing the amount of solute. What I'm doing? Say the Rufia. I'm increasing the amount of solute. Then the boiling point will increase. Yes or no?
Yes, sir.
Yes. Sir.
If I keep on increasing the amount of solute, the boiling point will keep on increasing, right? That means I can see the elevation in boiling point will be directly proportional to the concentration of the solution. And the concentration term that is directly proportional to delta TB was found out to be molality. And here delta TB, if I remove this proportionality sign, will be equal to a constant that is written as Kb into small m. Now what is Kb? Kb has a few names. It is known as molar elevation constant. It is also known as boiling point elevation constant. It has also another name that is known as ebullioscopic constant. Done, guys? Yes or no? Please tell me.
Yes, sir.
Okay. Now write the topic. Molar elevation constant. That is Kb. Okay. Molar elevation constant, that is Kb. We know that delta Tb is equal to Kb into molality, and Kb will be equal to what? Kb will be equal to delta Tb upon molality. And from here we can calculate the unit. The unit will be delta Tb will be in Kelvin. Molality will be in what? Molality will be upon moles per kg. This will be equal to Kelvin. Kg inverse will go above and will become kg. Divided by mole will go above and it will become mole inverse. Kelvin kg per mole. Also, now we should also write what is the definition of Kb. Now we will write for a specific case, that is for a 1 molar solution. That means a solution of molality 1. That means a solution having 1 mole per kg of solvent for a 1 molar solution. Please listen, don't write anything right now. Please listen. For a 1 molar solution, delta Tb will be equal to Kb into 1. For this specific case, it is equal to what? Kb into 1. And now what I can say that delta Tb is equal to Kb. That means Kb is the elevation in boiling point when the concentration of solution is 1 molar, right? Kb is the delta Tb. So right, Kb is the elevation in boiling point. Elevation in boiling point when 1 mole of solute is dissolved or is added per kg of solvent. Chali. Write this down. Let me know when you're done. Done, guys? Yes or no? Please tell me. Kirukia is done. What about Mohammed Saab?
1 minute, sir.
Okay.
That's it.
Done?
That's it.
Okay, okay. See, this is important, okay? Sometimes, many a times it has been asked, what is the unit of molar elevation constant or ebullioscopic constant? Okay, write the next topic again. That is determination of molar mass of solute. Similar topic as of RLVP. Definition of molar mass of solute using delta TB. That means elevation in boiling point. So what does elevation in boiling point say? It says that delta TB is equal to the molar elevation constant times molality. And we know that molality is equal to what? Number of moles of solute divided by the mass of solvent in kg. And kb into number of moles of solute will be equal to the WB upon MB, the given mass upon the molar mass into WA in kg. This is equal to what? Delta TB. Now what I will do, I will just replace this MB and I will keep it into the left hand side and I will get MB is equal to KB into WB upon delta TB into WA in kg. WA in kg. Now, again, if I have the WA in grams, then in order to convert it, I will have to write KB into WB into 1000 divided by delta TB into WA. And you can write this WA. You can plug in the value of WA as grams. Okay. यहाँ पे WA की value आप क्या लिखिएगा? Grams में लिख सकते हैं. Divided by 1000 है. Actually, it was divided by 1000 here. This 1000 went above and became into 1000 in the numerator. Okay. The denominator of denominator becomes the numerator. Denominator of denominator, it becomes numerator. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Okay. Again, this formula is not very important. This whole topic is important. You have to know how this formula has came into being. And the most important formula is this one, delta TB is equal to KB into M. So, okay, I'm not saying that you will not be using this formula anyway. I'm saying that it is not the most important formula. What is the most important formula? This one. You have to remember this no matter what. Let me know when you're done. Done all of you? Yes or no? Please tell me. Saif and Sayyida Rufia, please let me know if you're done. Sayyida Rufia is done. Mohammed Saif, just waiting for you.
Yes, sir.
Okay. Write a question. A solution of glycerol solution of glycerol in water was prepared by dissolving some glycerol in 500 gram of water. The solution has boiling point of 100.42 degrees Celsius. 100.42 degrees Celsius. What amount of glycerol was added to make this solution? Has been given Kb for H2O is equal to 0.52 Kelvin kg per mole. Chili, please write this question. Let me know when you're done. Okay. Both of you understand how to do this question? Yes or no? Please tell me. Saif and Saida Rufia.
Sir,
Yes, Saif. Now tell me.
what is the weight for okay, got it.
It's given, na? Everything is given, right? See, first of all, you calculate the delta TB. What is the delta TB? Yes, Saif and Saida Rufia.
dB minus d0b.
TB minus T naught B. So what is TB? It is equal to
100.42.
minus.
0.
Yes, Saif. Minus
0.
0. Why 0? Boiling point, na?
100.
Saida Rufia, am I audible? See the difference in temperature. I think Saida Rufia got disconnected. 0.42 Kelvin. If you even convert this values to Kelvin, now you will again get the magnitude of difference will be same in Kelvin scale and Celsius scale. Okay, please remember this magnitude of difference is same. Please remember difference है ना भाई. इसमें please don't get confused. Okay, the magnitude of difference absolute terms में तो अलग होगा. It's very clear. In absolute terms, that means if you have 100 degrees Celsius, it will be 273.15 Kelvin. But see, 100 degrees Celsius is equal to 273.15. 101 degrees Celsius is equal to 274.15. In दोनों में भी difference is what? 1, and the difference between these two is also equal to 1. Okay, so please remember that magnitude of difference is same in Kelvin and degree Celsius.
Yes.
Now you can easily write 0.42 Kelvin will be equal to kb into molality, and you can further write this as kb into wb upon mb into wa in kg. So we have to calculate wb na. So wb will be equal to 0.42 into mb into wa divided by kb. So molar mass of solute, write it as 92 grams per mole. Okay, you have to calculate, but for now I am giving you 92. Wa in kg. So the mass of solvent is given as 500 gram. That is in kg it will be equal to 0.5 divided by 0.52. Please calculate this and let me know the answer. Is this clear? Yes or no? Please tell me. Saf, let me know the answer. Yes, Saf, are you stuck
No, sir.
solving? Okay, simplify.